Okay, Assalamualaikum warahmatullahi wabarakatuh. My name Ahmad Amirul Ashraf bin Osman. My metric number is AE200001. Okay, in this video, I will explain about activity 1 and activity 2. For the activity 1, the procedure is have to create a circuit connection like this figure, and then set the DC voltage for 60 voltage. For the resistance value, put the resistance like the table given for 100, 200, 300, 400 and 500 resistance value. And then calculate the DC power using equation 3. Then compare the value, compare the calculated power for the simulated power. Okay. Now I will simulate this circuit in Proteus. This is the circuit that I create like a figure. For the 100 resistance value, we get the value of the power is 35.9. Okay, as we can see, we put a 36 power, and the calculated power is also 36. The value is same, and then we put 200 for the resistance value, and then we simulate. We get the power is 18, and then we calculate the power using manually. We get the same answer with the simulated, and for the next value of resistance also same. Okay, that's all for activity 1. Okay, for the activity 2, we also have to create a circuit like this figure, and then we have to set the AC voltage supplied to 100 voltage peak and 50 Hz. For the each resistance value given in table 6.2, which is 100, 200, 300, 400 and 500. We have to measure and record the peak voltage and real power using a simulation software. And then we have to calculate the real power using equation 4. Then compare the calculated real power that we simulate, and we calculated with the manually. Okay, this is the circuit that I have designed, and we have to do simulation for 100 resistance value. For the 100 resistance value, we get a 70.7 voltage and 50 watts for the real power. When we calculate, the answer also same, 50 watt. For the 200 resistance value, we have to change the value here, 200 value. Okay, and then we simulate. We also get the voltage, the peak voltage is also same, 70.7, and then the real power is 25 watts. We also get the same value when we do manually calculation. We get 25 watts, and same with 300 resistance, 400 resistance and 500 resistance, we get the same answer. When we change the value 300, then we simulate, we get the same answer for voltage and 16.7 watts. Also same when we calculate manually, we get 16.7 and so on. Okay, that's all from me. Thank you.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Amar Fikri bin Muhammad Nunaski. My matrix number is AE200004. Okay, today I will explain about activity 3, which is electrical power measurement in an AC circuit with capacitive load. Okay, so now we have 5 circuits, 1, 2, 3, 4, and 5. Okay, for this is the alternator. This is for AC ammeter, AC voltmeter, VA, watt, resistance, and capacitor. Okay, for the alternator, we set the amplitude is 100 volt, and the frequency we set 50 hertz. Okay, for the all circuit, we use the same value for resistor, which is 100 ohm, and for the capacitor, we use the difference value, which is 2 micro, 4 micro, 6 micro, 8 micro, and the last one is 10 micro. Okay, so let's run the circuit. Okay, for the 2 micro circuits, we got 3.14 for VA, and we got the 0.20 for watt. For the second circuit, which is 4 micro, we get 6.24 for VA, and we got 0.78 for watt. Next, for the 6 micro circuit, we we got the value for VA is 9.27 for VA, and 1.72 for watt. For the 8 micro circuit, we got the value for VA is 12.2 VA, and we got 2.98 for watt. Okay, the last one for 10 micro, we got the value for VA is 15.0, and the watt is we got the 4.50 watt. Okay. Okay. After we we do the simulation for the circuit. Okay. Here we got 5 circuits with the different capacitor, which is 2 micro, 4 micro, 6 micro, 8 micro, and 10 microfarad. Okay. Here we got the all value for the VA for the all circuits, and we got the value for simulated real power watt for the all circuits. Okay, now what we want to calculate is the power factor. Okay, first of all, in the calculation, we need to use this formula, which is Xc equal to 1 over 2 pi Fc. So we we put the value in the formula. After that, we need to use this formula Z equal to Z RL square at C square. Then we got the value. Next, we need to find the theta, which is the formula is inverse tan XC over RL, and we got the value, which is 86.0 degree. Then we use the cos, and the last thing that we need to find is the power factor, which is we use this formula. Power factor equal to true power or real power over apparent power. So we put the value that we got, and we got the answer. This is for calculation for circuit 1, which is we use the 2 microfarad for the capacitor, and this is for the second circuit, and use the same formula and same step. Same goes for the 6 microsecond and the 8 microsecond, and the last for the 10 microfarad circuit. After we got all the value for the power factor, we need to key in the value, the answer in this table. So we got all the value, the calculated power factor for the all circuit with different capacitor. All right. I think that's all from me. Thank you.